Kia ora Year 12. Here's question 3E from the 2016 Level 3 integration paper. The other two excellence questions are already done and they're on the external exams video playlist. So this is one where we do have to separate the variables. It looks horrible. It's actually not too bad at all if you just look at how to split up your functions. So I'm sorry in advance about a bit of background noise, but that's just how it's going to be. So let's look at what we've got. We've got sec x times dy by dx is equal to e to the y plus sine x. So first I'm looking at that and I'm not loving it because I've got y's and x's all mixed up here. I've got an x here and I've got dy by dx. But then I remember that I can split up this function and it all becomes quite doable. And the goal in the end here is to figure out what's y when x is equal to pi on 2. So we're going to separate the variables, integrate both sides, and then go on to solve the equation. So the first step, and I'm going to do this one quite slowly, is sec x dy by dx is equal to e to the y times e to the sine x. So now we've got the y and the x separate. It's looking better already. Sec of x is just 1 over cos x times dy by dx. So we're just about ready to do our wash around. So multiplying this through and this through to the other side first gives me dy is equal to e to the y, e to the sine x, cos of x, dx. Next step is to deal with the e to the y. So that's going to give me 1 over e to the y, dy on the left-hand side, and e to the sine x, cos x, dx over here. So we're ready to integrate on that side. Just going to change e to the y, sorry, 1 over e to the y to e to the power of negative y. And now we're good to integrate. So notice on the right-hand side that I've got a pattern quite similar to the excellence question in the 2017 pattern, only a wee bit easier. I'm going to use the chain rule backwards over here, and this is not bad at all either. So on the left-hand side we get negative e to the negative y. I'm not bothering to put the plus c because I'm going to collect it all up over on this side. So negative e to the negative y is equal to e to the sine x plus c. Now just take a careful look here. When I differentiate sine, I get cosine of x, and that's sitting here. So I don't need to muck around with the sign, the positive negative here. It's good as it is. I'll do one more little step. Get e to the negative y is equal to negative e to the sine x, and I'm going to write plus c dash. I've times through by negative 1, but I haven't made this a minus sign. I could write over here that c dash is equal to negative c. Remember, this is an arbitrary constant of integration, so we can be pretty fast and loose with it. Now I could go on to get y equals blah, 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 but I'm not going to. I'm going to go back to the question and look at what values I've been given. So we're told that when x equals 0, y is equal to negative 1. I'm going to substitute that in to figure out my constant here, and I've only got one constant term, so I just need 1 point. So carefully substituting in, I don't know why I've got a thing there, there's nothing there, right? So this is the equation that I'm working with. So now substituting in x equals 0, we get e to the negative 1 is equal to negative e to the power of sine 0 plus c dash, giving me e to the power of 1 is equal to negative 1 because sine 0 is equal to 0. So negative 1 plus c dash. So c dash is equal to e plus 1. Okay, so we've done most of the integration part. I'm going to write that back out into here nicely now. So we have e to the negative y is equal to negative e to the sine x plus e plus 1. The last thing we have to do is to evaluate the function. Well, it is a function, kind of. It's implicitly defined. We've got x is equal to pi on 2. What is y? So notice I haven't at any point here tried to make y the subject, because I don't need to figure out what y is. I can do it by substituting x into here and then solving for y. So e to the negative y is equal to negative e to the sine of pi on 2 plus e plus 1. Here's my sine curve. Sine of pi on 2 is 1. So we get e to the negative y is equal to negative e to the power of 1 plus e to the power of 1 plus 1. E to the negative y, these go, is equal to 1. So e to the power of what is equal to 1? 1 is just e to the power of 0. Negative y is equal to 0. Y is equal to 0. And we're done. Thanks for watching. I'll be back soon with the other missing integration videos.